righty, this is going on page 36 when we're done, right? Vertical asymptotes and holes, which we already have reviewed and we already understand. But we are going to tie these to limits. That's why we talked about limits on Friday, because I didn't want this to be the first time we even talked about the left and right limits, that sort of thing together. I think at the beginning of most of the lessons on rationals, it has said, recall, a rational function is the quotient of two polynomials. If you don't know that by now, you've definitely not been paying attention. They're both, the numerator and denominator, both polynomials. Numerator can be a constant. Denominator has to have a variable in it in order for it to be a rational, okay? Since we are dividing by a polynomial, rational functions have restrictions on their domain, right? And all their restrictions are the vertical asymptotes and the holes. Those are the things that mess up the domain. We know that whether it's a rational or not, we cannot divide by 0. If we divide by 0, what is our answer? Undefined. If we divide by 0, what is our answer? Undefined. It is not 0. It is not 1, which I hear sometimes for some, or negative 1. Let's make it negative if we don't know. I don't know. But it is undefined. That's right. You go to, exactly. Go to math jail. You don't want to have to go to math jail. Yeah, that's not where we should be. All right. All right. So we must consider any values where the denominator is equal to 0 and that they get restricted from the domain. These x values, so those that get restricted, those are either our vertical asymptotes or our holes. And then we know that the vertical asymptotes and holes both occur when the denominator of a rational function equals 0, because we can't divide by 0 and get a real number, right? And denominator is the bottom, denominator is down. I had that question earlier. I don't know, it really wasn't a question. Maybe it was more of a statement, like I get them mixed up or something like that. I don't know. But numerator is the top, denominator is the bottom. And so we're going to look at, we already know how to distinguish what they are. That is definitely old business, but we're going to tie them to our limit statements today. So a hole, again, a hole occurs when the factor in the denominator cancels out with the factors in the numerator. I know we know that. Y'all already knew that, and then we practiced that. A vertical asymptote occurs when a factor in the denominator cannot cancel out with factors in the numerator. Another way to say that is that it is unique to the denominator. It's other wording that you could definitely hear. All right. So let's talk about the holes. If I'm just looking at the equations, then we know that if we can cancel those out, that means I have a hole at x equals 1. We agree with that? That's old business. Here, if I look at g of x, I can cancel 2 of those out with 2 of those. And then it leaves an x minus 1 in the numerator. So I have canceled those out, which looks like I have a hole at x equals 1. The denominator, the zeros in the denominator gives me vertical asymptotes. What do the zeros in the numerator give me? What do those represent? They're the zeros of the function. The zeros in the numerator, the zeros of the function. So I've canceled these out, which again, usually tells us that we have a hole. But then I'm left with x minus 1, which also makes it look like I have a 0 at 1. You can't have both, right? Because a hole is a non-point and a 0 is an actual point. So what that really means is then here at 1, you have the hole on the x-axis. So if it looks like you have a hole and a 0, the hole wins out, okay? It just means we have a hole on the x-axis. That's not something I think that's come up before, so just want to make sure and understand that. Now these equations, neither one of these are the actual equations of this graph. This is just separate. So now we have a graph. When we have a hole on the graph, you literally have a hole in your graph. Unless you're graphing it in Desmos, you don't actually see the open circles. But when you drag your finger along it or you touch on those points, it'll say undefined, but it doesn't actually show you the open circle. On a graph on anything else, if you can't actually manipulate it, then it would, or that would be mean, because then how are you supposed to know, right? Now, when we look at the limits, if I have a limit that is approaching a number, so notice all 4 of these down here at the bottom, it's the limit as x approaches 1, either from the left or the right. If I'm approaching a number, I'm either approaching a hole or I'm approaching an asymptote. If I'm approaching a hole, then let's say that the whole, that's our refrigerator, right? You're in the living room watching TV, I'm in the garage. We both want some pizza. So we're both heading, you're heading in there from the left, I'm heading in there from the right. But when we get there, those pizza craving ninjas have taken the refrigerator and the pizza, right? So we never actually get the pizza, but we're both still heading to the refrigerator, right? As we're both approaching 1, our limit is what? 3. It's the y value. Good. This is the x value. This is the y value. So even though we're coming at it from different directions, because the whole is at 1, 3, as we approach 1, our limit is 3. Okay? Does that make sense? It's the y value. So if what you are approaching is a whole, your limit is the y value of the whole. Okay? We okay with that? All right. Now, when we look at the vertical asymptotes, all right, for f, I can't cancel anything out, so this is all I have left in the denominator. That tells me I have a vertical asymptote at x equals 1. Whole business, right? But on g, I can cancel stuff out. I can cancel this out with one of these, which looks like I have a whole at x equals 1. But because I left one down here, it also looks like I have an asymptote at x equals 1. But what wins out over the two is the vertical asymptote. So the vertical asymptote wins out over the whole wins out over the 0. So if you were going to rank them, this is the way it works. Vertical asymptote, whole, 0. If you think about this as just asymptote and not vertical asymptote, then it's in alphabetical order, if that helps. But vertical asymptote is king of everything. It wins out over the whole, but the whole wins out over the 0. Okay? So that means here I actually do have a vertical asymptote at x equals 1. Okay? So even though wholes and vertical asymptotes aren't new to you, the fact that you might have to distinguish between which one's more important, I think that part is new to you. Okay? But then when we look at the limits, so the graph here, if you have a vertical asymptote, you can see the vertical asymptote. I don't think that we have any problems with that, like that, I think, and I hope that makes sense to you. But if my limit is approaching an asymptote, when I'm approaching an asymptote, my answer is either positive or negative infinity, because I'm never going to run into the asymptote. I'm going to start heading towards it, but then I just have to hug it, either going to negative infinity or to infinity. So as I approach 1 from the left, my limit is negative infinity. As I approach 1 from the right, it's infinity. Okay? Everybody okay with that? What questions do you have? Anything? Nope. All right, let's flip it over. So we're just going to, on A, B, and C, we're just determining where they are. And I don't even have to, when we were doing these on the review part, if we would cancel something out and we found the x value for the whole, then we substituted it back in and found the y value to find the actual ordered pair. This just says for each function, determine the x values of any wholes or vertical asymptotes. So I don't even care about the y value here. I just care about the x value. There's a lot of what we do where maybe we could find the y value, but if it's all it's asking for is the x, that's all we care about, right? That's all we have to do. So when I look at A, I can cancel this out, right? Which means that I have a whole at x equals negative 3. But I'm not worried about the y value because nobody asked me for it. And then after I've canceled that out, I can also see that I have a vertical asymptote at what? X equals 5. Good. All right, you good with that? That's old business, right? We can figure that stuff out. Okay, so now on B, and just stay with me for a second because I'm going to start to contradict something I said on the front, but it'll make sense in the end. I can cancel out this x plus 1 with one of these, and I can cancel out this x minus 2 with one of these. So since I canceled stuff out, it looks like I have a whole at x equals negative 1 and x equals 2. Or I can just list it, okay? Right? Because when you cancel stuff out, that tells you you have a whole, yes? So then we go to look for our vertical asymptote. And I have a vertical asymptote at, well, this is what's left over, so that tells me I have a vertical asymptote at x equals negative 1. Can you have a vertical asymptote and a hole at the same place? No. Which one wins? The vertical asymptote. So I'm just going to go back up here and cross out that -1. So because I don't want you to, I mean, if you see, you don't have to write it down and then cross it out. But I think in general, that might help most people. You cancel stuff out, you go, ooh, I have a hole there. Then if you write down a vertical asymptote and you say to yourself, I can't have them both, and then you go back and you cross out the hole. I just think that's kind of a safe way to do it, okay? Questions about that? All right, let's look at C. I can factor the denominator, but even before I do that, am I going to have any holes? No, because factored or not, there's nothing to cancel out, right? So this has no holes. All right, so then when I factor this, I'm going to get 1 over x times x squared plus 4. Can I factor this anymore? No. So I look over here, I got a vertical asymptote at x equals what? 0. Okay. And then I got to figure out, I got to set that equal to 0, right? So if I do that, I get x squared plus 4 equals 0. So x squared equals -4. When I take the square root of both sides, x is equal to plus or minus 2 what? I. That's an imaginary number. Can I have a vertical asymptote at an imaginary number? No. Okay, so you don't even have to necessarily do what I did in orange. I wanted on your notes so that you know why we're saying we don't care about it, but it gives me an imaginary number. You don't necessarily have to show your work for that stuff. But basically, no matter what I substitute in there, this will never be 0, right? And if this will never be 0, this is not going to give me a vertical asymptote. Okay, so if you can recognize that you're going to get imaginary numbers, I only have one vertical asymptote, and it's at x equals 0. Okay, questions? All right, we good? All right, let's move on to the limit stuff then. So this says left and right limit statements. Now, we talked about left and right in behavior. That's when we're heading to infinities. We're not heading to infinity here. I do have left and right limits, but it says as x approaches 2. So before I worry about my equation or anything else, I know that this will start off like the limit as x approaches 2 from the left, you put that little negative sign up there, of f of x, and the limit as x approaches 2 from the right of f of x. Okay. Everybody good so far? So then let's look at what we have up here. I don't have any holes, right? Holes, I have none. But I do have a vertical asymptote at x equals 2. So since 2 is where an asymptote is, I'm either going to positive or negative infinity. By just glancing at this, I don't know which one I'm going to, right? So I have to determine if it's negative, negative, positive, positive, negative, what it is. So in order to do that, I need to do a sign chart, but not necessarily the whole thing, because I am not solving an inequality. I don't care where everything is positive and negative. I just care about what's happening around my asymptote. So I know I have an asymptote at 2. Okay, got a vertical asymptote at 2. I also have zeros at 1 and -3. Now I'm putting those on there to help me, but I'm not going to, like I said, I'm not going to do the whole sign chart. I only care about either side of the asymptote. The reason it can be very helpful to have that on there is that when I go to the left of 2, I can't use 1. And I don't want to use 0 either, because it needs to be between those two. So having that on there tells me basically I need to use like 1.5. Okay, so that's really the only reason it helps me. So 1.5 minus 1 is positive. 1.5 plus 3 is positive. 1.5 minus 2 is negative, so that is negative overall. Then on the right, it's a free-for-all, so I can use 3. It's fine. 3 minus 1 is positive, positive, positive. That's positive overall. So what that tells me is as I approach 2 from the left, I'm heading to negative infinity. As I approach 2 from the right, I'm heading to infinity. Okay? That's one reason why I kind of showed y'all, I kind of drew stuff on those sign charts when I said we didn't have to, just so you could kind of get a feel for what's happening. So as I approach from the left, it's negative infinity. As I approach from the right, it's infinity. Okay. What questions you got? Anything? All right. So let's go ahead and start our limit statements. The limit is x approaches 2 from the left. Limit as x approaches 2 from the right. And those are both g of x. Okay, so here I can cancel this out, which means I have a whole at x equals 2, and I have a vertical asymptote at x equals 3. Because this question is asking me to write my limit statements as I approach 2, I really don't care that I have an asymptote at 3, right? I only kind of care because maybe I would need to put it on a sign chart or something, but I'm approaching a hole this time. When I'm approaching a hole, am I going to positive and negative infinity? No. When my limit as I approach the hole is what part of the graph? The y value of the hole, right? So what I need here is just the y value. I don't need to do a sign chart for this one. So here, I'm just going to find g of what? 2, because the x value for the hole is 2, and I plug that into the reduced version, so it's really just this part here. So this will be 2 plus 4 over 2 minus 3. That gives me 6 over negative 1. So the answer to both is just negative 6. Okay? You do the sign chart for the asymptotes, because you got to know if you're going to positive or negative infinity. For the hole, you don't need a sign chart. You just need to know what the y value of the hole is. Okay? We good with that? Questions? Anything? Easy peasy lemon squeezy. All right. Now, let's look at C. I can cancel this out with one of these, which looks like I have a hole at x equals 2. Then I check for my vertical asymptotes. I got one at x equals 2 and one at x equals 1. Do we see an issue here? Yes, we can't have a vertical asymptote and a hole at the same time. Which one wins? Vertical asymptote. And this is why, even though we saw that we have a hole at 2, we went ahead and looked at our vertical asymptotes, because I don't actually have that hole there to use. I'm going to use the vertical asymptote. Okay, you with me on that? All right, so let's go ahead and write out our limit statements here. Limit as x approaches 2 from the left, h of x. Limit as x approaches 2 from the right of h of x. All right, so am I going to find h of 2? No, because I'm approaching an asymptote, so I got to do my sign chart, right? So on this sign chart, I'm going to put that 2. I'm also going to put 1 and 4, because those are all the things that would have to go on it if I was doing the full sign chart. And again, that just kind of helps me with what numbers to choose, but I'm not filling out the whole thing. I only care about what happens right around here. So that tells me here, again, that I have to choose something like 1.5, right? So 1.5 minus 4 is negative. 1.5 minus 2 is a negative. Minus 1 is positive. So that's positive overall. Between 2 and 4, I can pick 3, so that would be negative, positive, positive. That's negative overall. Right? And so then This side's going to infinity. This side's going to negative infinity. So as I approach from the left, infinity. As I approach from the right, negative infinity. What questions do you have? Sign charts have lots of applications. Okay. We good? Any questions at all? All right. Now we're going to challenge your brain some here. So this wording says, write an equation. It doesn't say write the equation. So the equation implies there's one. An equation implies there's more than one. There's actually an infinite amount that we could write, but we don't need to get fancy. Even though there's an infinite amount, if we all did this individually, we'd probably end up with the same ones because we might as well just do the simplest one you can, right? Of a rational function with the following properties. All right, so let's talk about what these things tell us. If I have the limit as x approaches 3 from the left and right is 5, what's happening at 3? A whole. Okay, so I have a whole. Not only is it happening at 3, but I know that the y value is 5, right? Then the limit as x approaches 1 is either negative or positive infinity. So what's happening at 1? Vertical asymptote. Okay, so basically we're working backwards here, right? We were given that stuff, then we wrote the limit statements. Now we have the limit statements and we're figuring out that stuff. Okay, then because we know this, we can write equations, or we can write an equation that would give us these properties here. So this is f of x. Okay, I know that if I have a whole at 3, 5, then I had to have a factor of x minus 3 in the numerator and 1 in the denominator so that they would cancel out so that I would get a whole at 3, right? And then if I have a vertical asymptote at x equals 1, then I have to have a factor of x minus 1 in the denominator. Okay, do we agree with that much? So we're just kind of working backwards. But now I got to check on a couple of things. I got to check on whether or not I'm really going to negative infinity and infinity, and I got to check on my y value over there. I would suggest that we check on the vertical asymptotes first, which means, again, I'm going to look at a little sign chart. And I'm going to have this at 1. There's where my vertical asymptote is, right? And I don't know anything about zeros or other vertical, like maybe there's other vertical asymptotes. I don't know, but that's kind of the best I can do. So I just got to get real close on either side of 1. So if I approach 1 from the left, now when I do this, I always use my reduced version, right? So even though this light blue would be my answer, if I really like canceled out the zeros, this would give me f of x equals 1 over x minus 1, so that I would have that vertical asymptote. And I can do the sign chart with this. So to the left of 1, I can do 0. That would be negative. To the right of 1, I could do 2. That would be positive. So that means that as I approach from the left, I'm going to negative infinity. As I approach from the right, I'm going to infinity. Is that what my limits say? Yes. If it was opposite, then I would need to put a negative sign out front. Okay, that's what I'm looking at, so that it would flip it around. But I think I'm good on that, so I'm good. The other thing I need to look at is I need the, shrink that up a little bit. I need my y value for the whole to be 5. So if I find f of 3, okay, if I substitute it into my reduced version, that's going to give me 1 over 3 minus 1, which is 1/2. I don't want it to be 1/2. I want it to be 5. So what would I have to have in the numerator for this to equal 5? 10, right? So after I canceled that out, if this was 10, then 10 over 2 is going to give me 5, right? Which would mean I would need this to be 10, which means I need a coefficient of 10 right there. And if y'all are like last period, they were like, we get it. We don't like it, but we get it. But Do I need to say any of that again? You see how you kind of work backwards? All right, so let me take that back out and say it again. Okay, if I want the y value of the whole, I evaluate the reduced function at the x value. If I substitute it into what I have written right there, I'm going to get 1/2. I don't want 1/2. I need that to be equal to 5, right? And that's 1/2. That ain't 5. But what can I divide by 2 to get 5? I can divide 10 by 2, which means I would need this to be 10, which would mean I would need that to be 10, which means when I cross these two out, I still need a 10 up here, so I need a coefficient of 10, okay? Here's the good news. I am going to have you write a couple of these on your assignment because I want you to use your little brains. But when it comes down to it on a real exam, you would be given these properties and be given a list of functions that you would have to choose from. So if you can write them, then you could choose them from a few of them, okay? This is just making you think a little bit harder and make sense of it, okay? We good on that? Questions? Okay. So let's check out this next one. What is happening on B at -2? A whole. Because if my limit as I approach -2 is a number, then I have a whole at, and that would actually be at -2, 4. Okay. And then because I'm going to the infinities here, I would have a vertical asymptote at x equals -1. Everybody okay about how to get that from the limits? All right, so then we start to build an equation. This is f of x again. And by the way, over here, this, even though we don't normally box our answers, there's a lot going on, so I'm going to do that. That's my answer. I used the reduced version to help me with stuff, but like, that's my answer. I know nothing about the horizontal asymptotes or anything else. I mean, right here for this one, I'd have a horizontal asymptote at 10, but who knows, there might be something else going on where, you know, that would still work out. All right, so f of x. I know if I have a whole at -2, I have to have a factor of x plus 2 in the numerator and denominator so that they would cancel out. Okay? If I have a vertical asymptote at -1, what do I have to have in the denominator? X plus 1. Very good. Okay. Everybody okay with all that so far? Yes? All right, so now we're going to check our vertical asymptotes. It's a good idea to do those first. So vertical asymptote at -1. And I'm going to use the reduced version of this, f of x equals 1 over x plus 1. So to the left of -1 would be like -2. So -2 plus 1 would be negative, right? And if I use 0, 0 plus 1 would be positive. So if this is my asymptote, then on the left, I'm heading to -infinity, and on the right, I'm heading to infinity. Is that what I want? No. Okay, because this says infinity and infinity. That's not what I have here. What can I do to this to make these both positive? Well, if I put a negative in front of it, it's going to change both of them. Okay, if I just put a negative in the front, it flips them both. I don't want to do that. No, it would be squared. That's how we make everything positive. If I have a double root, that's when it doesn't change on either side. If they're both going to infinity or -infinity, it's because something is squared there, okay? So that means that this x plus 1 would actually be squared here. And then that flips this around and makes it positive like that, okay? We good with that? Now, I need to check my output here. If I find f of -2 in this would be 1 over -2 plus 1 squared. Well, -2 plus 1 is a -1, but I square it, so it becomes a what? 1. So I get 1 over 1. But I don't want 1 over 1. I want what? 4, which is basically means I want 4 over 1. So if I want this to be 4 over 1, then this would need to be a 4, which means this needs to be a 4, and I need a 4 right there. Okay? Nuna, you got that? Need to stand up and do some jumping jacks? I just realized I can see you fading. I hadn't heard a peep out of y'all. Out of you. Have y'all noticed that? Not a peep. Nobody's laughed today. Nothing. You okay? All right. We okay with the 4? Yes? Sort of, maybe? Okay. You get it, but you don't like it? That's okay. We don't have to always like it. Love it. That's good. All right, so we're going to sketch a picture. I have a rational function that has these properties. So instead of coming up with an equation, we're going to graph something. And it's, again, a picture. It doesn't mean it's the graph. Because what this information doesn't tell us is what kind of asymptote do we have? Do we have a horizontal? Do we have a slope? If it's horizontal, where is it? We don't know any of that, right? So we can just kind of guess and assume some things about that. It straight up tells us where the holes are. And then it tells us as we approach 4, we're increasing and decreasing, which means I have a vertical asymptote at x equals 4. Okay, so we're going to graph this. And I'm going to put 1, 2, 3, 4. And the other reason I'm even putting any little hash marks is because I have holes and I want to make sure I'm putting them at the right spot. Okay. And again, no idea where the horizontal asymptote is. So no reason to get crazy. Let's say it's at y equals 0. Wouldn't that be the easiest thing? Just use the x-axis. So as x approaches 4 from the left, it increases without bound, which means we're going to positive infinity here. And I have a hole at x equals 1. So I can put the hole here, and then it can just come in and look something. Well, that is not good at all. Something like that. Something like that, right? And then as x approaches 4 from the right, it decreases without bounds, so it looks something like that. Okay. And again, you wouldn't have to actually graph these. You would be given this information, be given a few graphs, and have to match up which one would make the most sense. Okay, we good on that? All right, so I want you to draw B while I hand out the assignment. And then we will talk about it. That might be an extra one, but they're like stuck together, so. Make sure that's enough. Is that enough of them? Yeah, okay. Is there an extra? Okay. I'll give you another second, sorry. I'm going to draw 2 different versions. I'm going to draw what probably most of y'all drew, and then I'm going to show you, like, because again, in case it's multiple choice, I don't want you to be locked in and just the only thing you think it could be. So here's what I know. In both versions, I have a vertical asymptote at x equals -1. So at -1, I have a vertical asymptote, no matter what I'm doing there. If we are going to assume that we have a horizontal asymptote at y equals 0, because again, why not? That's the easiest, right? I have a hole at -2 and at 3. So here's -2. I could have a hole right here, and this could come in and look something like that. And then I have one at 3. So it might come in and look something like that, right? Close enough. Do you have something that sort of resembles that? Nope. Is that what you said? Oh, you said yes. Okay. That's okay. All right, but that's us assuming that we have a horizontal asymptote at y equals 0. And you don't have to draw a second one. It's up to you. But let's say that our horizontal asymptote is up here. Because, again, we don't know. Because our hole is not necessarily down low either. It could be. Maybe the hole is right here. And it looks like, well, it wouldn't go through that point then. It would look something like this, but better, right? Always better than whatever I have. And then the one at 3, maybe it's up here. Okay, so if you were having to match it up, both of these fulfill all of that, right? They don't look the same, but they both fulfill that. So don't get too trapped into specific things. As long as all that stuff is true, then you're good, okay? Everybody okay with all that? Any questions? All right, good deal. Oh, yes, go ahead. I'm sorry. Yeah, you can. That's fine. That's why this one's fine. We can just assume it's right here because we don't know. Like if you're having to draw it. But I wanted to show you more than one because if you're not drawing it and you're choosing it from different graphs, just know that it doesn't necessarily mean it's at y equals 0. Like you have no way of knowing from the information that's given to you. So it could be anywhere. Yeah. And it could be a slant asymptote for all we know. As long as the other stuff is true, then we're good. Okay. Good question. Anything else?